safely break down nutrient molecules like glucose and to drive energy. Carbon dioxide, which is harmful, is also released during the above catabolic reactions. O2 has to be continuously provided to the cell. Carbon dioxide produces by the cell having to be released out. The process of exchange of O2 from the atmosphere with carbon dioxide produced by the cell is called breathing, commonly known as respiration. Respiratory organ mechanism of breathing vary amongst different group of animals depend mainly on their habit and level of organizations. Lower invertebrate like sponges, Coelenterata, flatworm, etc. exchange O2 with carbon dioxide by simple diffusions over their entire body surface. Earthworm use their most cuticles and insects have a network of tubes like tracheal tubes to transport atmosphere air with the body. A special vascularized structure called gills are used by most of the aquatic arthropoda and mollusks. Where vascularized bag called lungs are used by the terrestrial form for the exchange of gases. Among vertebrate, fish use gills, where reptiles, birds, and mammals respire through lungs. Amphibians like frogs can respire through their moist skin. Reptiles, birds, and mammals respire through lungs. Amphibians like frogs respire through the moist skin. Also, mammals have a well-developed respiratory system. Human respiratory systems. We have a pair of external nostrils open out above the upper lips. It leads to a nasal chamber through a nasal passage. The nasal chamber open into the pharynx, a portion of which is common passage for food and air. The pharynx open through the larynx regions into the trachea. Larynx is a cartilaginous box which help in sound production and hence called a sound box. During swelling, glottis can be covered by a thin elastic cartilaginous flap called epiglottis to prevent the entire of food into the larynx. Trachea is a straight tube extended up air to the middle thoracic cavity, which divide at the level of fifth thoracic vertebrae into a right and left pulmonary bronchioles. Each bronchioles undergo repeated divisions to form the secondary and tertiary bronchioles and bronchioles, ending up in very thin terminal bronchioles. The trachea, primary, secondary, and tertiary bronchi, and initial bronchioles are supported to incomplete cartilaginous ring. Each terminal bronchioles give rise to a number of very thin, irregular walled and vascularized bag-like structure called alveoli. The branching network of bronchi and bronchioles and alveoli comprises the lungs. We have two lungs which are covered by a double-layered pleura with pleural fluid between them. It reduces frictions on the lung surface. The outer pleura membrane is in close contact with the thoracic. This structure is epiglottis, larynx, trachea, bronchus, cut end of ribs and lungs, pleural membranes, alveoli, pleural fluid and bronchioles, diaphragm. lining where the inner pleura membrane is in contact with a lung surface. The parts starting with a external nostrils up to a terminal bronchioles consisting the conducting part where the alveoli and their duct form the respiratory or exchange part of the respiratory system. The conducting part transports the atmosphere to the alveoli clearly. It clears it from foreign particles humidified and also bring the air to body temperature. Exchange part is the sites of actual divisions of O2 and carbon dioxide between blood and atmosphere air. The lungs are situated in the thoracic chamber, which is anatomically an airtight chamber. The thoracic chamber is formed dorsal by the vertebral column, ventral by the sternum and lateral by the ribs, and on the lower sides by the dome-shaped diaphragm. The anatomically setup of lungs in the thoracic is such that any change in the volume of the thoracic cavity will be reflected in the lungs like pulmonary cavity. Such an arrangement is essential for breathing. We cannot directly alter the pulmonary volume. Respiratory respirations involve the following steps. First step, breathing or pulmonary ventilations, by which atmosphere air is drawn in and carbon dioxide rich alveolar air is released out. Second step is diffusions of gases like O2 and carbon dioxide across alveolar membrane. Third step is transport of gases by the blood. Fourth step is a diffusions of O2 and carbon dioxide between blood and tissue. Fifth step is a utilization of O2 by the cell for catabolic reactions and resultant release of carbon dioxide like cellular respirations as डिटेल्ड जो हम लोग चैप्टर 14 में पढ़ते हैं. अब मैकेनिज्म ऑफ ब्रीथिंग. Breathing involves two steps like inspirations, during which atmosphere air is drawn in, and expirations, by which the alveolar air is released out. The movement of air into and out of the lungs is carried out by creating a pressure gradient between the lungs and the atmosphere. Inspirations can occur if the pressure with the lungs, like intrapulmonary pressure, is less than the atmospheric pressure. That is, there is a negative pressure in the lungs with respect to atmosphere pressure. Similar expirations takes place when the intrapulmonary pressure is higher than the atmospheric pressure. The diaphragm and a specialized set of muscles, external and internal intercostals between the ribs, help in generations of such gradient. Inspirations is essential by the contractions of diaphragm which increase the volume of thoracic chamber in the anterior posterior axis. The contractions of external intercostal muscles lift up the ribs and the sternum, causing an increase in the volume of the thoracic chamber in the dorsal ventral axis. The overall increase in the thoracic volume causes a similar increase in the pulmonary volume. An increase in pulmonary volume decrease the intrapulmonary pressure. A increase in pulmonary volume decrease the intrapulmonary pressure to less than the atmospheric pressure, which force the air from outside to move into the lungs. That is inspirations. And relaxations of the diaphragm and the intercostal muscles retain the diaphragm and sternum to their normal positions and reduce the thoracic volume and thereby the pulmonary volume. This lead to an increase in the intrapulmonary pressure to slightly above the atmospheric pressure, causing the explosions of air from the lungs, that is expirations. We have the ability to increase the strength of inspirations or expirations with the help of additional muscles in the abdomen. On an average, a healthy human breathes 12 to 16 times per minute. The volume of air involved in the breathing movement can be estimated by using a spirometer, which help in clinical assessment of pulmonary functions. एयर एक्सपेल्ड, यहाँ क्या होता है? एयर एंटरिंग लंग्स, इसमें एयर एंटर करता है. रिब्स एंड स्टेनम रिलीज्ड, वॉल्यूम थोरेसिक इंक्रीजेस एंड रिब कैच. ये क्या है? डायफ्राम कॉन्ट्रैक्ट करता है. एयर एक्सपेल्ड फ्रॉम आउट, एयर बाहर से जब करेंगे. रिब्स एंड स्टेनम रिटर्न टू ओरिजिनल पोजिशन, वॉल्यूम ऑफ थोरेसिक डिक्रीजेस एंड डायफ्राम रिलैक्स्ड एंड आर्च्ड अपवर्ड. Respiratory volume and capacity. Tidal volume. Volume of air inspire or expire during a normal respiration is called tidal volume. What is tidal volume? Tidal volume, the volume of air inspire or expire during a normal respiration. It is a approx 500 milliliter. A normal respirations, it is approx 500 milliliter. A healthy man a healthy man can inspire or expire approximately 6,000 to 8,000 milliliter of air per minute. Inspiratory reserve volume IRV. What is IRV? Additional volume of air a person can inspire by a forceful inspirations. The average is 2500 to 3000 milliliter. Expiratory reserve volume ERV. Additional volume of air a person can expire by a forceful expiration. This average is 1000 to 1100 milliliter. Residual volume, volume of air remaining in the lungs even after a forceful expiration. The average is 1100 to 1200 milliliter. By adding up a few respiratory volume described above on can derive a various pulmonary capacity which can be used in clinical diagnosis. Inspiratory capacity IC, total volume of air a person can inspire after a normal expiration. This includes tidal volume and inspiratory reserve volume. Inspiratory capacity क्या है? Tidal volume plus inspiratory reserve volume. Inspiratory reserve volume. Tidal volume is a inspiratory capacity is TB plus IRV. Inspiratory capacity is TB plus IRV. Functional residual capacity FRC. Functional residual capacity, volume of air that will remain in the lungs after a normal expirations. This includes ERB plus RV. Expiratory capacity like ERB plus RB. IC is inspiratory capacity is TB plus IRV. ERV like EC. Expiratory capacity like TB plus ERV. Functional residual capacity like expiratory reserve volume plus residual volume. Vital capacity, the maximum volume of air a person can breathe in after a forced expiration. This includes expiratory reserve volume, tidal volume and inspiratory reserve volume, or the maximum volume of air a person can breathe out after a forced inspiration. Total lungs capacity, total volume of air accommodated in the lungs at the end of forced inspirations. This includes RV, ERV, TB, and IRV. Vital capacity plus residual capacity is called total lungs capacity. Total lungs capacity is a vital capacity plus residual volume. Exchange of gases. Alveoli are the primary sites of exchange of gases. Also occur between blood and tissue. O2 and carbon dioxide are exchanged in these sites by the simple diffusions mainly based on pressure like concentrations gradient. Solubility of gases as well as the thickness of the membrane involved in diffusions are also some important factors that can affect the rate of diffusions. Pressure contributed by an individual's gas in a mixture of gases is called partial pressure and is represented as PO2 for oxygen and PCO2 for carbon dioxide. Partial pressures of these two gases in the atmospheric air and the two sides of diffusions are given. And in gradient for oxygens from alveoli to blood and blood to tissue similar. रेस्पिरेटरी गैसेस क्या होता है O2 एंड कार्बन डाइऑक्साइड लाइक एल्वोल एटमॉस्फेयर एयर लाइक एटमॉस्फेयर में ऑब्वियसली है कि ऑक्सीजन ज़्यादा होगा कार्बन डाइऑक्साइड कम होगा इसीलिए एटमॉस्फेयर में क्या होता है 159 होता है ऑक्सीजन एंड 0.3% होता है कार्बन डाइऑक्साइड एल्वोलाई में भी क्या होगा क्योंकि हम लोग को सेल को ऑक्सीजन चाहिए तो एल्वोलाई में भी ऑक्सीजन की मात्रा ज़्यादा होगा लाइक 104 टू और कार्बन डाइऑक्साइड क्या होगा 40 लेकिन डीऑक्सीजनेटेड ब्लड में क्या होगा ऑक्सीजन की मात्रा कम होगा लाइक 40 होगा एंड कार्बन डाइऑक्साइड 45 ब्लड में क्या होगा 95 ऑक्सीजन एंड 40 कार्बन डाइऑक्साइड टिश्यू में क्या होगा टिश्यू में क्योंकि ऑक्सीजन चाहिए तो वहाँ ऑक्सीजन कम होगा और कार्बन डाइऑक्साइड ज़्यादा इंस्पायर्ड एयर inspire air expire alveoli like partial pressure of O2 is 104 and partial pressure of carbon dioxide is 14 ये क्या है carrying oxygenated blood like systematic arteries like carrying oxygenated blood partial pressure of oxygen is 95 millimeter Hg and partial pressure of carbon dioxide is 40 millimeter Hg carry deoxygenated blood like veins partial pressures of O2 like 40 millimeter Hg and partial pressure of carbon dioxide is 45 millimeter of mmHg. A gradient is present for carbon dioxide in the opposite direction that is from tissue to blood and blood to alveoli. As the solubility of carbon dioxide is 20 to 25 times higher than that of O2. The amounts of carbon dioxide that can diffuse through the diffusion membrane per unit difference in partial pressure is much higher compared to that of O2. The diffusion membrane is made up of three major layers, namely the thin squamous epithelium alveoli, the endothelium of alveoli and capillary, and the basement substance in between them. The diffusion membrane is made up of three major layers, namely a thin squamous epithelium alveoli, the endothelium of alveolar capillary, and the basement substance. Diffusion membrane is made up of three major layers like squamous epithelium of alveoli and endothelium of alveolar capillary and the basement substance in between them. However, its total thickness is much less than a milliliter. Therefore, all the factors in our body are favorable for diffusions of oxygen from alveoli to tissue and that of carbon dioxide from tissue to alveoli. Basement substance red blood cell basement substance red blood cell blood capillary and alveolar transport of gases transport of gases Transport of gases. Blood is the medium of transport of oxygen and carbon dioxide. About 97% of oxygen is transported by RBC in the blood. The remaining 3% of O2 is carried in a dissolved state through the plasma. Nearly 20 to 25 percentage of carbon dioxide is transported by the RBC, where 70 percentage of it is carried as bicarbonate and 7 percentage of carbon dioxide is carried in a dissolved state through plasma. Transport of oxygen. Hemoglobin is a red colored iron contain pigment present in the RBC. Carbon dioxide can bind with hemoglobin in a reversible manner to form oxyhemoglobin. Each hemoglobin's molecules can carry a maximum 4 molecules of O2. Binding of oxygen with hemoglobin is primarily related to partial pressure of oxygen, partial pressure of carbon dioxide, hydrogen ions concentrations, and temperature are the other factor which can interfere with this binding. A sigmoid curve is obtained when percentage saturation of hemoglobin with O2 is plotted against the PO2. This curve is called as oxygen dissociation curve and is highly used in studying the effect of factors like partial pressure of carbon dioxide, H plus concentrations, etc. on binding of oxygens with hemoglobin in the alveoli where there is high partial pressure of O2, low partial pressure of carbon dioxide, lesser H plus concentrations, and low temperature. The factors are all favorable for the formations of oxyhemoglobin. High partial pressure of O2 and low partial pressure of carbon dioxide, lesser H plus concentrations, and lower temperatures. The factors are all favorable for the formations of oxyhemoglobin, where in the tissue where lower partial pressure of oxygen, higher partial pressure of carbon dioxide, and higher H plus concentrations and higher temperature exist. The conditions are favorable for dissociations of oxygens from the oxyhemoglobin. This clearly indicates that O2 get bound to hemoglobin in the lung surface and get dissociated at the tissue. Every 100 milliliter of oxygenated blood can deliver around 5 milliliter of O2 to the tissue under normal physiological condition. Transport of carbon dioxide. Carbon dioxide is carried by hemoglobin is carbamine hemoglobin about 20 to 25 percentage. This binding is related to the partial pressure of carbon dioxide. Partial pressure of oxygen is major factor which could affect this binding when partial pressure of carbon dioxide is higher and partial pressure of oxygen is low as in the tissue. More binding of carbon dioxide occur whereas when the partial pressure of O2 is lower and partial pressure of O2 is high as in the alveoli dissociation of carbon dioxide from carbamine hemoglobin take place. Carbon dioxide which is bound to hemoglobin from the tissue is delivered at the alveoli like RBC contain a very high concentrations of enzymes like carbon anhydrides and minute quantities of the sum is present in the plasma too. The enzymes is facilitated. Carbon dioxide plus water. Use of carbon anhydrides like H2CO3 and carbonic anhydrides like HCO3 at the tissue site where partial pressure of carbon dioxide is high due to the catabolism. Due to the catabolism, carbon dioxides diffuse into blood, RBC, and plasma and form HCO3 and H plus at the alveolar site where partial pressure of carbon dioxide is low. Then reactions proceeds in the opposite direction leading to the formations of carbon dioxide and H2O. Alveoli is released out as carbon dioxide. Every 100 milliliter of deoxygenated blood deliver approximately 4 milliliter of carbon dioxide of the alveolar. Regulations of respiration. Regulations of respirations. Human beings have a significant ability to maintain and moderate the respiratory rhythm. Regulations of respirations. Human beings have a significant ability to maintain and moderate the respiratory rhythm to suit the demand of the body tissue. This is done by the neural system, a specialized center present in the medulla regions of the brain called respiratory rhythm center is primarily responsible for the regulations. Another center present in the ponus regions of the brain called as pneumotaxic center like center can moderate the functions of the respiratory rhythm centers. Neural signal from the for this center can reduce the durations of inspirations and thereby alter the respiratory rate. A chemosensitive area is situated as adjacent to the rhythm center, which is highly sensitive to carbon dioxide and hydrogen ions. Increase in the substance can activate the center, which in turn can signal the rhythm center to make necessary adjustment. In this respiratory process by which this substance can be eliminated, receptors associated with aortic arc and carotid artery also can recognize change in the carbon dioxide and H plus concentration and second necessary signal to be rhythm center for remedial actions. The role of oxygens in the regulations of respiratory rhythms is quite insignificant. Disorder or respiratory systems. Asthma is a difficult in breathing, causing wheezing due to inflammations of bronchioles and bronchioles. Emph- Emphysema is a chronic disorder in which alveolar wall are damaged due to which respiratory surface is decreases and one of the major cause of the cigarette smoking. Occupational respiratory disorder in a certain industrial especially those involving gradient or stone breaking. So much dust in provide that is defense mechanism of the body cannot full cope with the situation. Long exposures can give rise to inflammations leading to fibrosis like proliferations of fibrous tissue and thus causing serious lung damage. Workers in such as industrial should wear protective mask. Body fluid. Now the next chapter is body fluid, and circulation. Body fluid and circulation. All living cells have to be provided with nutrient like O2 and other essential substance. Also, the waste or harmful substance provided have to be removed continuously for healthy functions of tissue. If it is therefore essential to have efficient mechanism or for the movements of the substance to the cells and from the cells. Different group of animals have evolved different method for this transports. Simple organisms like sponges and ciliata circulate water from their surrounding through their body cavity to facilitate the cell to exchange tissue. This substance more complex organisms use a special fluid within their bodies to transport such material. Blood is the most commonly used body fluid by most of the higher organisms, including human. For this purpose, another body fluid like limbs also help in the transports of certain substance. In this chapter, we will learn about the compositions and properties of blood and limbs, tissue fluid, and the mechanism of circulations of blood is also explained here. Blood is a special connective tissue consisting a fluid matrix, plasma, and from elements. Plasma क्या है? Plasma is a straw colored viscous fluid containing nearly 55 percentage of the blood, 90 to 92 percentage of the plasma in water, and protein contributed 6 to 8 percentage. Fibrinogens, globulin, and albumin are the major protein. Fibrinogens are needed for clotting or coagulations of blood. Like globulin, primarily are involved in defense mechanism. Globulin क्या है? Defense mechanism है. Albumin is help in osmotic balance. Small amount of minerals like sodium, calcium, magnesium, HCO3, Cl minus etc. Glucose, amino acid, lipid etc. also present in the plasma as they are always entrenched in the body factor for coagulations or clotting of blood are also present in the plasma in the inactive form like plasma without the clotting factor called serum. Plasma without the clotting factor is called serum. Form element is a 45 percentage like erythrocytes क्या बोलते हैं आरबीसी most abundant of all the cell in the body. A healthy adult man has an average 5 millions to 5.5 millions of RBC like millimeter per cube of blood. RBC are formed in the red blood red red bone marrow in the adult. RBC are divided up nucleus in most of the mammals and are biconcave in shape. They have red colored iron containing complex protein called hemoglobin. 12 to 16 gram of hemoglobin in 100 milliliter of blood. Lifespan of RBC is 120 days एंड डिस्ट्रॉयड इन द स्प्लीन लाइक ग्रेवयार्ड ऑफ आरबीसी कहते हैं. ल्यूकोसाइट को क्या कहते हैं? डब्ल्यूबीसी, जो कलरलेस होता है लाइक न्यूक्लिएटेड होता है एंड आर रिलेटिवली लेजर इन नंबर विच एवरेज 6000 टू 8000 मिलीमीटर पर क्यूब. इसमें क्या होता है? डब्ल्यूबीसी डिवाइड करता है ग्रेनुलोसाइट एंड ए ग्रेनुलोसाइट. न्यूट्रोफिली, इस्नोफिली एंड बेसोफिली आर डिफरेंट टाइप्स ऑफ ग्रेनुलोसाइट्स. And neutrophil are the most abundant cell like 60 to 65 percentage. Basophils are the least like 0.5 to 1 percentage. Neutrophil are most abundant cell like 60 to 65 percentage and basophil are the least abundant like 0.5 to 1 percentage. Neutrophil are monocytes like 6 to 8 percentage. Neutrophil and monocytes are 6 to 8 percentage. Neutrophil and monocytes are 6 to 8 percentage. 6 to 8 percentage. Phagocytosis like basophils secrete histamine, serotonin, and heparin. Basophils secrete histamine, serotonin, and heparin involved in inflammatory reactions like eosinophily like 2 to 3 percentage. Rest infections and are also called as associated with allergic reactions. क्या है? RBC, platelets, eosinophil like head से basophils, neutrophil, monocytes, T lymphocyte and B lymphocytes. Lymphocyte like 20 to 25 percentage. Both B and T lymphocytes like immunoresponse of the body called lymphocytes, thrombocytes, cell fragments, megakaryocytes, special cell in the bone marrow like 1 lakh 50,000 to 3 lakh 50,000 platelets millimeter per cube. Platelets can release a varieties of substance, most of which are involved in the coagulations or clotings of bloods. A reducing in their number can lead to clotting disorder, which will lead to excessive loss of blood from the body. Blood grouping ABO and Rh negative are widely used all over the world. Presence or absence of two surface antigen on the RBC contain two natural antibodies protein produced in response to antigen. Contain two natural antibodies protein produced in response to antigen like A, B, AB and O. Blood transfusions like compatibility. Blood group A, B, AB and O. Antigen on RBC. ब्लड ग्रुप ए का एंटीजन होता है ए, बी का एंटीजन बी, ए बी का दोनों एंटीजन होता है ए और बी, ओ का नील कोई एंटीजन नहीं होता है. ब्लड ग्रुप ए का एंटीबॉडी लाइक एंटीबॉडी जो होता है ए ब्लड ग्रुप रहेगा उसका ऑपोजिट होता है एंटी बी. बी का एंटी ए बी का नील नहीं होता है एंड ओ का क्या होगा एंटी ए एंड एंटी बी. डोनर ब्लड ग्रुप ए वाले को ए ओ दे सकता है, बी वाले को बी ओ दे सकता है, ए बी को ए बी दे सकता है, ए दे सकता है, बी दे सकता है, ओ दे सकता है. यानी ए बी को सब दे सकता है, ओ को सिर्फ ओ ही देगा. ओ ब्लड group B donated to persons with any other blood group and here O group individually are called as universal donor. Persons with AB group can accept blood from persons with AB as well as the other group of blood. Therefore, such persons are called universal recipients and O is a universal donor. Rh grouping. Another antigen, the Rh antigens, similar to one present in rhesus monkey. Nearly 80% of humans, such individuals are called Rh positive, and those in whom this antigen is absent are called as Rh negative. Rh group should also be matched before transfusions. Rh incompatibility mismatch has been observed between the Rh negative blood of a pregnant mother with Rh positive blood of the fetus. Rh antigen of the fetus do not get exposed to the Rh negative blood of the mother in the first pregnancy. The two bloods are well separated by the placenta. During the delivery of the first child, there is a possibility of exposures of the material blood to small amounts of Rh positive blood from the fetus. In such cases, the mother start preparing antibody against Rh antigen in her body. In case of her sequence like pregnancy, the Rh antibody from the mother Rh negativity can leak into the blood of the fetus Rh positive and destroy the fetal RBC. This could be fatal to the fetus or called causes serve anemia, and jaundice to the baby. Erythroblastocytes fetalis. This can avoid by administering anti-Rh antibody to the mother immediately after the delivery of the first child. This can avoid the administering anti-Rh antibody to the mother immediately after the delivery of the first child. Coagulations of blood. Blood exhibit coagulations or clotting, like prevent excessive loss of blood from the body. Dark reddish brown skin formed at the site of a cut or an injury over a period of time. Clot or coagulations form mainly of a network of thread called fibrin. Dead and damaged form elements of blood are trapped, like fibrins are formed by the conversions of inactive fibrinogens into the plasma by the enzymes thrombin, prothrombin, and enzymes complex thrombokinase. Cassidy's process set an injury or a tumor stimulates the platelets in the blood to release certain factor which act, activate the mechanism of coagulation. Certain factor released by the tissue at the site of injury also can initiate coagulation. Calcium ions play a very important role in clotting. Limbs like tissue fluid. As the blood passes through the capillary in tissue, some water along with many small water soluble substances move out into the spaces between the cell of the tissue, leaving the large protein and most of the formed elements in the blood vessels. This fluids released out is called as interstitial fluid or tissue fluid. It has the same mineral distributions as that in the plasma. Exchange of nutrient gases etc. between the blood and the cell always occur through these fluids. An elaborate network of vessels called as lymphatic system collective these fluids and darkening it back to be major vein. The fluid present in the lymphatic systems is called lymph. Lymph is a colorless fluid contain specialized lymphatic which are responsible for the immune response of the body. Lymph is also an important carrier of nutrient hormones etc. Fat are absorbed through lymph in the lateral portions in the interstitial villi. Circulatory pathway. The circulatory pattern are of two types, open or closed. Arthropodia and mollusks in which blood pumped by the heart passes through large vessels into open space or body cavity called as cyanosis. Annelida and chordata have a closed circulatory system. Annelida and chordata have a closed circulatory system. Annelida and chordata have a closed circulatory system in which the blood pumped by the heart is always circulates through a closed network of blood vessels. This pattern considered to be more advantage as the flow of fluid can be more precisely regulated. All vertebrates possess a muscular chambered heart. Fishes have a two-chambered heart with a atrium and ventricles. Amphibians and the reptiles exhibit crocodile have three chambers. Amphibians and the reptiles except crocodiles have three chambers. Heart within two arteries and a single ventricles. Crocodiles, birds, and mammals possess a four-chamber heart within two arteries and two ventricles. In fish, the heart pumped out deoxygenated blood which is oxygenated by a gills and supplied to the body parts form where deoxygenated blood is returned to the heart like signal single circulations. Amphibians and reptiles, the left atrium receive oxygenated blood from the gills, lungs, skin, and the right atrium get deoxygenated blood from the other body parts. However, they get a mixed up in a single trickle, which pump out mixed blood in complete double circulations. Birds and mammals oxygenated and deoxygenated blood received by the left and right artery respectively passes on to the ventral of the same sides. Ventricles pumped it out without any mixing up. Two separate circulatory pathways are present in these organisms, hence these animals have double circulation. Human circulatory system. Human circulatory system, also called the blood vessel system, consists of a muscular chambered heart, a network of closed branching blood vessels and blood the fluid which is circulate. Heart is mesodermal derived like thoracic cavity between the blood's lungs slightly tilted to left like clenches fist protected by a double walled membrane bag like pericardium unclosing the pericardial fluid. Two relatively small upper chamber called artery and large lower chamber called ventricles. Two smaller upper chamber called artery and large lower chamber called ventricles. A thin muscular wall called a intra-atrium septum. Thick walled and intraventricular septum. Thick fibrous tissue called the arterioventricular septum. The open between the right atrium and the right ventricle is irritated by a valve formed by three muscular flips of capsa. The tricuspid valve is bicuspid or mitral valve. Grades of opening between the left atrium and the left ventricles. The opening of the right and left right and the left ventricles into the pulmonary artery and the aorta respectively are provided within the semilunar valve prevent any backward flow. And entire heart is made up of cardiac muscles. Wall of ventricles are much thicker than wall of heart is much thicker than wall of ventricles are much thicker than that of artery. A specialized cardiac muscular called as nodal tissue is also distributed in the heart. A patch of the tissue present in the right upper corner of the right atrium called the sinusus artery nodes SA nodes. Another mass of this tissue is seen in the lower left corner of the right atrium close to the arterioventricular septum called the arterioventricular nodes. A bundle of nodules, fibrous arterioventricular bundles, AV bundles, continuous from the AV nodes which passes through the arterioventricular septa to emerge on the top of the intraventricular septum and immediately divided into the right and left bundles. Thus, branches give rise to minute fibrosis throughout the ventricular muscular of the respective side and are called Purkinje fibrosis. The nodules of musculature has the ability to generate action potential without any external stimulus. Nodal musculature has the ability to generate action potential without any external stimulus. That is, it is auto-excitable. SA nodes can generate the maximum number of action potentials, that is 70 to 75 times per minute. Hmm. Cardiac cycle. How does the heart function? Let us take a look to begin with all the four chambers of heart are in the relaxed state. They are in joint distal as the tricuspid and bicuspid valve are open. Blood from the pulmonary vein and vena cava flow into the left and the right ventricles, respectively, through the left and right atria. Semilunar valves are the closed at the stage. The SA nodes now generate an action potential which stimulates both the artery to undergo a stimulus contractions. The stimulus both the artery to undergo a stimulus contractions. The arterial systole the increase the flow of blood into the ventricles by about 13 percentage. The action potential is condi- conducted to the ventricular sides by the AV node and AB bundles from where the bundles of has transmitted it through the entire ventricular muscular to musculature. This causes the ventricular muscles to connect ventricular systoles. Arterial undergoes relaxation. Distoles coinciding with the ventricular systoles. Ventricular systoles increase the ventricular pressure, causing the closure the tricuspid valve. Bicuspid valve due to the bicuspid valve due to attempted backflow of ventricular Bicuspid valve due to attempted backflow. Ventricular pressure increase the further the semilunar valve gradient grading the pulmonary artery right side and the aorta left side are forced open, allowing the blood in the ventricles to flow through these vessels into the circulatory pathway. The ventricles now relax ventricular diastole and the ventricular pressure falls causing the closures of semilunar valve which prevent the backflow of the blood into the ventricles as the ventricles pressure declines further the tricuspid and bicuspid valve. SA node generate a new action potential. The cardiac cycle consists of systole and diastole of both the atria and ventricle 72 times per minute. Durations of cardiac cycle is 0.8 seconds. During a cardiac cycle, each ventricle pump out approximately 70 milliliter of blood, which is called the thoracic volume, stroke volume multiplied by the heart rate. Stroke volume multiplied by the heart rate give the cardiac output. Stroke volume multiplied by the stroke volume multiplied by the heart rate gives out number of beats per minute. Lenny give the cardiac output. Therefore, the cardiac output can be defined as the volume of blood pumped out by which ventricles per minute and average is 5000 milliliter like 5 milliliters. In a healthy individual, the body has the ability to alter the stroke volume as well as the heart rate and thereby a cardiac output. For example, the cardiac output of an athlete will be much higher than that of a ordinary man. During each cardiac cycles, two prominent sound are produced which can be easily heard through the a stethoscope. The first heard sound is love and the associated with closures of tricuspid valve. First heard sound is love and dove. First heard sound is love, the closures of tricuspid valve and bicuspid where the second heard sound is dove is associated with closure of seminal valve, closure of tricuspid valve and bicuspid secondary heard sound associated with closures of seminal valve. Electrocardiograph like ECG mechanism. Electrocardiograph used to obtain an electrocardiogram. ECG is a graphical represent of the electrical activity of the heart during cardiac cycle. Three electrical leads on each wrist and to the left and to the left ankles like PQRS and T wave. P wave represent the electrical extensions or depolarizations of the artery, which leads to contractions of the both artery. QRX complex represent the depolarizations of ventricles artery, depolarizations of artery and depolarizations ventricles, which initiates the ventricular contraction, artery contraction, ventricular contractions. The T wave represents the return of the ventricles from the excited to normal state like repolarizations. Depolarizations artery and depolarizations ventricles. T wave represents the return of the ventricles from excited to normal state like repolarizations. The end of the T wave marks the end of systole. By containing the number of QRX complexes that occur in a given time period, ONS can determine the heartbeat rate of an individual's. And deviations indicate a possible abnormality or disease, hence, it is a great clinical significance. Double circulations. The blood flow is directly by a fixed rotate through blood vessels. The arteries and veins basically each arteries and veins consist of three layers: an inner lining of squamous endothelium, the tunica intima, a middle layer of smooth muscles and elastic fibers, the tunica media, and an external layer of fibrous connective tissue with collagen fiber and tunica externa. Tunica media is comparatively thin in the veins. I mentioned early the blood pumped by the right ventricles entered the pulmonary artery. Left ventricles pumped blood into the aorta. Oxygenated blood is carried out the pulmonary vein into the left atrium. Oxygenated blood enters the aorta. Oxygenated blood is carried out the pulmonary veins into the left atrium. Pulmonary circulation. Oxygenated blood entering the aorta is carried out the network of arteries, arterioles, and capillaries to the tissue, from where the deoxygenated blood is collected by a system of venules, veins, and vena cava, and emitted into the right atrium. This is the systematic circulation. A unique vascular connection exists between the digestive tract and liver called as hepatic portal system. The hepatic portal vein carried blood from intestine to the liver before it is delivered to the systemic circulations. A specifical coronary systems of blood vessels is present in our body exclusively for the circulations of blood to and form of the cardiac musculature, lungs, pulmonary vein, dorsal aorta, vena cava, smooth muscles, lumen, aorta, capillary, regulations of cardiac cavity, normal cavity activity of the heart are regulated interstitially, auto-regulated by specialized muscles like nodal tissue. Heart is called myogenic. A special neural central in the medullary oblongata can moderate the cardiac functions through autonomic nervous systems like ANS. Neural signal through the systematic sympathetic nervous part of ANS or ANS can increase the rate of heartbeat, the strength of ventricular contractions, and thereby the cardiac output. On the other hand, parasympathetic sympathetic nervous sign, another component of ANS, decrease the rate of heartbeat, speed of conduction, conductions of actions potential, and thereby the cardiac output. Adrenal medullary Hormones can also increase the cardiac output. Disorder of circulatory system, high blood pressure like hypotension. इसमें क्या होता है, हाई हायर देन नॉर्मल. नॉर्मल कितना, 120/80, इससे ज़्यादा हो जाता है. In this measurements 120 millimeter Hg, like millimeter of mercury presence is the systole, or pumping pressure is itna systole and diastole. Resting pressure, if repeated check of blood pressures of an individual is 140/90, then 140/90 higher it is, so hypertension, high blood pressure lead to heart disease and also affect vital organ like brain and kidney. Coronary artery disease, CAD. Coronary artery disease often referred to the atherosclerosis affect the vessels that supply blood to the heart muscles, deposit the calcium fat like cholesterol and fibrous tissue, which makes the lumen of arteries narrow. Angina pectoris, acute chest pain, no enough oxygen is reaching the heart muscles, occur in men and women of any age, but it's more common amongst the middle age and el- elderly. Heart failure, not pumping blood effectively enough to meet the need of the blood. Congestive heart failure, like congestion of the lungs, is one of the main symptoms of the disease. Heart failure is not the same as cardiac arrest when the heart stops beating, or a heart attack when the heart muscles is suddenly damaged by an inadequate blood supply. Now next chapter is excretory product and their elimination. You have already learned that the neural system provides as point-to-point rapid coordinations among organs. Fast but short-lived, as the nerve fibers do not innervate all cells of the body. And the cellular functions need to be continuously regulated. A special kinds of coordinations and integrations has to be provided. This functions is carried out by hormone. The neural systems and the endocrine system jointly coordinated and regulate the physiological functions in the body. Endocrine glands and hormones. Endocrine glands lack duct and here hence called as ductless gland. Their secretions are called hormones, chemical provided by endocrine gland and released into the blood and transported to the distantly located target organ. Hormones are non-nutrient chemicals which act as intracellular messengers and are produced in trace amounts. Invertebrate possess very simple endocrine systems with few hormones, where a large numbers of chemicals act as hormones and provide coordinations in the vertebrate. Human endocrine systems. The endocrine glands and hormones producing diffuse tissue select in different parts of our body consisting the endocrine system like pancreas, gonads, testes in men and ovary in female, gastrointestinal tract, liver, kidney, heart also produce hormone. Pineal, hypothalamus, pituitary, hypothalamus, pineal, thyroid and parathyroid, ecthymus, pancreas, adrenal and testes in male and ovary, adrenal, pancreas, thymus, thyroid and parathyroid, pineal, thalamus and pituitary. The hypothalamus base part of the diencephalon forebrain. Several group of neurosecretory cell called as nuclei. Several group of several group of neurosecretory cell called as nuclei regulate the synthesis and secretions of pituitary hormones. How the hormones produced by hypothalamus are of two types: the releasing hormone, which stimulates secretions of pituitary hormones, and the inhibiting hormone, which inhibits secretions of pituitary hormones. For examples, a hypothalamic hormone called gonadotropin releasing hormone GnRH stimulates the pituitary synthesis and release of gonadotropin. On the other hand, somatostatin from the thalamus inhibit the release of growth hormones from the pituitary. These hormones originated in the hypothalamic neuron pass through axon and are released from their nerve ending. These hormones reach the pituitary glands through a portal circulatory system and regulate the functions of the anterior pituitary. Posterior pituitary is under the direct neural regulations of the hypothalamus. The pituitary gland is located in the bony cavity called as sella turcica and is attached to the hypothalamus by a stalk. It is divided anatomically into a adenohypophyse and neurohypophyse. Adenohypophyse consists of two portions, pair distal and pair end parts intermediated. The parts distalized regions of pituitary, commonly called as anterior pituitary, produces growth hormone, prolactin, thyroid stimulating hormone, adenocorticotropic hormone, luteinizing hormone, and follicles stimulating hormones. Pairs intermedia secrete only one hormone called as melanocyte stimulating hormone. However, in the human, the pairs intermediate is almost migrate with pars distal. Neurohypophyseal nervous, also known as the posterior pituitary, store and release two hormones called oxytocin and vasopressin, which are actually synthesized by the hypothalamus and are transported axonally to neurohypophysia. Oversecretions of growth hormone stimulated abnormal growth of the body, leading to gigantism, and low secretions of growth hormone stimulate the result in pituitary dwarfism. Excess secretions of growth hormones in adult, especially in middle age, can result in several disfigurement, especially in middle age. in face and acromegaly lead to serious complications and premature death if unchecked. The disease is hard to diagnose in the earlier stage and often goes undetected for many years until change in external features become noticeable. Prolactin regulate the growth of the mammary glands and formations of milk. TSH, thyroid stimulating hormone, stimulates the synthesize and secretes thyroid hormones from the thyroid glands. ACTH stimulate the synthesis and secretion of steroid hormones called as glucocorticoid for the adrenal cortex. LH and FSH stimulates gonadal cavity and hence are called gonadotropin hormones. In male, LH stimulates the synthesis and secretes of hormones called androgens from testes in male. FSH and androgens regulate spermatogenesis in female. LH induced ovulations or fully mature follicles maintain the corpus luteum formed form the remain of the graphene follicles after ovulations. Follicular stimulating hormones stimulate growth and development of the ovarian. Hypothalamic neuron, portal circulation, posterior pituitary, anterior posterior portal, hypothalamus, hypothalamic neuron. Follicles in female, MSH act on the melanocyte melanin contains cell and regulate pigmentations of the skin. Oxytocin act on the smooth muscles of our body and stimulate their contractions. In female, the stimulates a vigorous contractions of uterus in the time of childbirth and male ejaculations. From the mammary gland, vasopressin act mainly at the kidney and stimulates resorptions of water and electrolyzed of by the distal tubules and thereby reduce loss of water through urine diuresis. Hence, it is also called antidiuretic hormone. An, im- an impairment affecting synthesize or release ADH results in an increased ability to the kidney to conserve water, leading to water loss and dehydration. This condition is known as diabetes insipidus. The pineal gland. The pineal gland is located on the dorsal sides of the forebrain. Pineal gland secrete a hormone called melatonin. Melatonin play a very important role in regulations of a 24-hour diurnal rhythm of our body. For examples, it helps in maintaining the normal rhythm of sleep wake cycle, body temperature. In addition, melatonin also influences metabolism, pigmentations, the menstrual cycle, as well as defense capability. Thyroid gland. The thyroid gland is composed of two lobes which are located in either side of the trachea. Both the lobes are interconnected with the thin plate of connective tissue called isthmus. The thyroid gland is composed of follicles and stromal tissue. Each thyroid follicle is composed of follicular cells enclosing cavity. Thus, follicular cells synthesize two hormones like testosterone like T4 and T3. Iodine is essential for the normal rate of hormone synthesis in the thyroid. Deficiency of iodine in our diets results in hypothyroidism and enlargements of the thyroid gland, commonly called as goiter. Hypothyroidism during pregnancy causes defect developments and maturations of the growing baby, leading to stunted growth like cretinism, mental retardations, low intelligence, abnormal skin defect, mutism, etc. In adult human, hypothyroidism may cause menstrual cycle to become irregular due to cancer of the thyroid gland or due to developments of nodules of the thyroid glands. The rate of synthesis and secretions of the thyroid hormones is increased to abnormal high level, leading to a condition called hyperthyroidism, which adversely affected the body physiologically. Like exothalamic goiter is a form of hyperthyroidism characterized by the enlargement of the thyroid gland. Protections of the eyeballs increase basal metabolic rate and weight loss is also called Graves' disease. Thyroid hormone play an important role in the regulations of basal metabolic rate. These hormones also support the process of red blood cells formation. Thyroid hormones control the metabolism of carbohydrate, protein, and fat, maintenance of water and electrolytic balance is also influenced by thyroid hormone. Thyroid glands also secretes a protein hormone called thyrolectin, thyrocalci, thyrocalcitonin (TCT), which regulate the blood calcium level. In human, four parathyroid glands are present on the backside of the thyroid gland, on pair each in the two loops of the thyroid glands. The parathyroid gland secrete a peptide hormone called as parathyroid hormones PTH. The secretion of PTH is regulated by the circulating level of calcium ions. Parathyroid hormone PTH increase the calcium level in the blood. Like PTH acts on bone and stimulates the process of bone reabsorption, like dissociation, like demyelination. PTH also stimulates reabsorption of calcium by the renal tubules and increased calcium absorption from the digest food. It is thus clear that PTH is a hypercalcemic hormone. It increases the blood calcium level along with TCT. It plays a significant role in calcium balance in the body. Thymus. The thymus gland is a lobular structure located between the lungs behind sternum on the ventral side of the aorta. Developed by the immune system, secrete the peptide hormone called as thymosin. Differentiations of T lymphocytes, cell-mediated immunity, promote production of antibodies to provide humoral immunity. This degenerated in old individually resulting in decreased productions of thymosin. As a result, the immune response of old persons become weak.